Liquid leaked from a damaged tank at a rate of R of T liters per hour. The rate decreased as time passed, and values of the rate at 4-hour time intervals are shown in the table. So at at the start of this thing, 0 hours, the rate, it was leaking out at 9.1 liters per hour. This is, yeah, it says liters per hour. Um, okay, and then at the 4-hour mark, it was leaking out 8.4 liters per hour. It slowed down a little bit. At the 8-hour mark, it was leaking a little slower, et cetera, et cetera. Notice the units. If we take hours and we multiply by liters per hour, hours are going to cancel and we're going to get liters. We're going to get the total amount leaked out during that time, right? And that's what they want. And they say find a lower estimate for the total amount of liquid that leaked out during the first 20 hours. Okay. So let's say, okay, so from 0 to 4, during those first 4 hours, the leak rate at the start of that time was 9.1, but by the end it slowed down to 8.4. So what we're going to do is we're going to take 4 times just the 8.4. Why? Because they want a lower estimate. In other words, it started leaking at 9.1, but we don't know how long. It might have gradually got down to 8.4. It probably did, but just to give a lower or underestimate, we're going to assume it was just 8.4 during that whole 4 hours, right? We know it started at 9.1, a rate of 9.1. And by the end, it had gone down to a rate of 8.4. So a lower or underestimate, lower estimate, which you take the lower of those two numbers, 8.4. So let's just pretend it leaked out at a rate of 8.4 liters per hour for that whole 4 hours. That'd be 4 hours times 8.4 liters each hour. Will give you the total liters that leaked out during those 4 hours, at least an underestimate of that. Plus, and then the next 4 hours from 4 to 8, it started at 8.4 and ended at 7.8. So for 4 hours, we'll assume it leaked out at least 7.8, right? That'd be an underestimate, a lower estimate, right? During that 4 hour period, it started at a rate of 8.4. By the end, it was down to a rate of 7.8. So it leaked out at least 7.8 for 4 hours. Plus, and you get the pattern, right? For the next 4 hours, started at 7.8, ended at 7.2. So it leaked out at least, always taking the lower of the two numbers in the interval. Looked at least 7.2, right? Next 4 hours from 12 to 16 started at 7.2, ended at 6.7. We'll go with the lower. Did at least that. We're going to get how much it leaked out at least. And then the last 4 hours, it started at 6.7, ended at 6.2. So it leaked out at least 6.2 liters every hour for 4 hours. So the quick way to do it is just, they all have a 4. So just put the 4, just factor out the 4 and add up all the other numbers. Multiply like that. Quicker on Desmos. By the way, you might wonder, well, Mr. Aaron, we never used the 9.1, right? We don't have that. Where's that? Yeah, that's right, because that was, we were, and for each interval, we were taking the lower. So for these first two, we did the lower, next two lower, etc. So we never used 9.1. That was the highest overall number. So that's not, they asked us for a lower estimate. If they wanted an upper estimate, then we would do that. Let's go to Desmos. So it's for 8.4, 7.8, 8.4, 7.8, 8.4, 7.8, 8.4, 7.8, 7.267, 7.267 plus 6.2. 145.2. I think that's what we saw, right? Yeah, 145.2. There it is. 145.2 liters. That's how much. So that's an underestimate. That means they lost at least 145.22 liters, certainly more. So they just gives us a rough estimate of how much leaked out during that time period. It's the same thing as the area under the curve. That's why we're doing it. And there we go.